Welcome back to session 2 of Introduction to Data Science and Healthcare using R. I'm your host, Matt Hershey, and I'm joined today, same as yesterday, by our inexhaustible TAs, Ali and Akshay, who are going to be manning the message and chat boards down to the side there. If you have any questions anytime, ask them. They will try to point you in the right direction. A couple of housekeeping things. Today, much like yesterday, we will be using RStudio Cloud in order to deliver this content to you. I will also be delivering some slides to you. The slides have an interactive component, again, just like yesterday, where you can put some code exactly in the slide or in those code chunks within the slide and follow along. Today we have more opportunities to take our Markdown document files that we worked with yesterday. And we have some new ones for you today that have some code that we will then move back and forth between RStudio Cloud and the slides that I'm showing you. So again, like yesterday, I would recommend that you position your browser. Again, I'll be off to the right-hand side. It might be useful, again, so you have the content that we're delivering along with the slides sort of side by side that you can then compare and contrast. And so with that, we will dive right in. I know that some people were a little bit tardy yesterday. Hopefully you can get caught up to speed. We have a lot of information, just like yesterday, to cover today. Today's quite exciting. We have data visualization is going to be the primary thing that we're covering today, using a package called GGplot. In the homework that we assigned last night, I'll just show you one plot. We will dive deep into that to look at GGplot and look at how we can make really sophisticated data visualizations from our data in very few lines of code. We will then transition into some more advanced concepts, including importing our data into the RStudio environment. We'll be working with strings, which is very different than working with numbers. And then finally, we will wrap up the day wrap up this session looking at the reproducible report generation using a package called R Markdown. So as always, we will have an opportunity for you to ask questions. We will then highlight some of these questions if they're going to be useful for the rest of the group. Without further ado, we will dive right into it. All right, so again, welcome back. This is session 2 of our introduction to data science and healthcare using R. I'm just getting everything sort of set up here. I left you yesterday with this piece of homework that really is going to be a launching point. I wanted you to sort of explore. If you didn't have an opportunity to explore, that's completely fine. It was just really for you to play with the code a little bit and develop so many questions that you can come today with these questions that hopefully will answer to you. And we start with this quote by John Tukey saying, the simple graph has brought more information to the data analyst's mind than any other device. And this is John Tukey of the Tukey box plot fame. And this is really one of the ideas that's driving us is we have data. And the data, what we went over yesterday, is stored in data tables and is stored in data frames. But we have to get those data out and into a format that is interpretable and understandable and digestible. We talked about this concept of an exploratory data analysis. And within that, really, we want to visualize because the visualization is what helps us understand what we're looking at. And that really is going to be one of the key ideas that is driving us today. So with that, we are going to then dive right into and spend most of our time today working with this package called GGplot2. And GGplot2 is a very rich package with so many capabilities. We will just scratch the surface. But my hope for you today is to be able to take what we learned yesterday about some of this data manipulation. And we're going to then bookend it with both sides. We'll talk about the data importing, and then we'll talk about the data visualization. So by the end of the day, my hope for you is to be able to take a data set, import it, manipulate it as you need to, and visualize it. And so we're going to start with the visualization because the visualization is quite satisfying and intuitive. And so I left you yesterday with this basic plot in the homework that I assigned. If you didn't get a chance to look at it, that's fine. It's really just an opportunity to explore. But what we looked at was this code here, and this code generated this plot. And really what it is, it's quite simple. It's individual points that are going to be telling us the serum cholesterol value for patients within this heart disease data set. And then this is stratified by males versus females. And so with just a couple of lines of code here, and most of the code is cited in the labels here, we can then look at some of these data. So this is quite powerful. But I also highlight this graph because there are several things wrong with it. We have no idea, for example, how many points are here. The points are overlapping. We have no idea about summary statistics. If we wanted to say who has a higher levels of serum cholesterol between men and women, we wouldn't really be able to tell because there could be many, many more men or women sort of in that blue line there. And so there are plenty of other ways that we will explore today to make this plot better. All right, so Ali and Akshay were able to answer some people's questions about this, this sort of early exploratory plot. But then I'll just sort of pause for a moment and ask, are there any questions from last week, either about the homework, which we'll get into more, but are there any questions about dplyr? Are there any questions about the concept of a data frame? Are there any sort of burning questions that we want to review? We will review some of those concepts again today. But I want to make sure that we have opportunities to light up the chat board if we need to do that. So I'll just take a moment and let any of these come through if there are questions. Okay. So we have some people sort of making predictions about the code and so on. All right, so let's dive into this package called GGplot2. GGplot2 is, like I said, it's a very rich package used for data visualization. And this sort of simple format is going to drive all GGplot2 code. And so I put it to you in a very generic format. This is highly extendable and not specific to really any data set, because this is the template. So if you are taking notes at home, or if you have the slides printed out, or if you're writing something somewhere, this is the template that you need in order to construct a rich data visualization. So we start out with the function GGplot. And just like our functions from yesterday, this is a word, in this case, GGplot is the function. There's no quotes around it, and then it is bracketed with parentheses about the thing that we're going to do. So we're going to do this to that, just like we talked about yesterday. So we are going to GGplot to the data frame. And that's what we show here. So we say data equals data frame. So the data frame here is going to be the name of the data frame. We used a data frame yesterday called heart. We'll use that extensively again today just for consistency. And so if we were going to plot this for heart, we would say ggplot, parentheses, data equals, and then heart, parentheses. Now, this is a little bit different because what we have here is we're constructing several layers of a ggplot, and we'll get into that concept in just a second. But instead of writing the pipe, what we're going to do is we're going to add these layers to this. So the pipe is going to string together several different functions. And what we're doing here is we're stringing together different layers. And so we're not stringing them together in terms of a pipe, but instead we're stringing them together, we're adding them together in terms of layers. And so this layered concept is going to become very important for making some of these data visualization tools. Okay, so we take ggplot data equals data frame, and in our case, for much of today, it will be heart. Then we're going to add a geom. The geom is a geometric transformation, which is the way that we tell GGplot what kind of plot we want it to make. So there are several different types of geoms, and again, we're going to go into the specifics of what they are. But this is a layer where we say what we want to do with this data. If we want to make a dot plot or a scatter plot, that will be one thing. If we want to make a histogram, that will be another geom histogram, it turns out. If we want to make a column graph, if we want to get into more sophisticated tools, this is where we are going to tell ggplot what kind of plot we want to make. Okay, now this is also a function, so then we have parentheses. And in here, what we're going to do is we're going to now start to be specific about what elements of the data frame that we want to explore, that we want to visualize. Now this is important because if you remember from yesterday, heart had 15 variables. It had several different variables, including sex, cholesterol levels, age, and on down it went. And now when we explore some of these and when we plot some of these, what we want to do first is we want to plot very specific relationships. Let's say we want to look at cholesterol levels by gender, which is what we did previously. And so we would then identify what are the different X and Y axes, and that's exactly what the second layer does. we write AES, and AES stands for aesthetic, is the first 3 letters of the word aesthetic. And then in that, we're going to define our X and our Y. So we're going to map X and Y to a geometric transformation within a data frame, all wrapped in our GGplot function. So this is the template. We'll do this several times today. And this is what we'll always come back to. Okay, so again, we went through this. You can look at this template. You can see that we assign a name to a data set and map it to a type of variable. So if we wanted to then look at, here's another example. So if we want to take our heart data again, now we're adding a little bit more specificity because before it was a template and we didn't have any specifics. But here we are saying data equals heart, so we know that we're working in the heart data frame. And then we want to say, instead of geom, we're going to define the geom. We're going to say geom_point. So fortunately, all of these geoms that we're going to be working with start with GEOM and then an underscore, and then another part where in this case it's going to be point. And this is just going to be a scatter plot. And then we say mapping equals our aesthetic, and we're going to be comparing age versus this other variable. Now, what is this other variable? So this is interesting because what we would want to do is we want to have what we call a data dictionary for this heart data set. So if we go to GitHub, and then we go to the repository for where all of this information of this code is. And so if you look up here, you can see this is github/MatthewHershey/tidybiology-+ds. There I put a data dictionary. You can also find it at this site, which is the Kaggle machine learning competition site, which is where we got the data from. But here I cut and paste and sort of tried to define what the different values are for you. So if you want, you can then just sort of keep this open on the side, and we can then go down and we can see this THALCH is maximum heart rate achieved. So this is an exercise-induced heart rate value. And so we can now come back to here. We can say, okay, well, what is the maximum heart rate achieved under some sort of load that then is compared to age? And what we can see is now this is a scatter plot because we use geom_point. And there you can look at the relationship between age and heart rate. And maybe you could find some trends where some of the younger people are able to achieve some high heart rates. In fact, this just under 30-year-old was able to get a heart rate over 200 under exercise. And then as we get older, the 70-year-olds, this looks like a quite fit 70-year-old, but we can see that there are some more aged people that are have a lower heart rate value, maximum heart rate value in this data set. Okay, so what we can now start to do is compare different variables. And this is now a specific example. We go from the template to a very specific example. This is what the 2 lines of code is going to generate our plot for us. All right, moving along. Now, I really want to just sort of take this step by step because this is going to be the most important thing for you to learn in order to build your own GGplots. So we initialize this plot again with GGplot. And here, that's this line where we have GGplot data equals heart. And then we plus, and now we add layers. And we have these geometric functions that are going to define the different layers. So in this case, geom_point is our scatter plot. And again, we then map our aesthetic. This is very important here, where on the inside of the parentheses for the aesthetic, we are going to then say X is going to equal age, Y is another variable. In this case, it's the heart rate, the maximum heart rate achieved under stress. Okay, now a couple of notes on GGplot style. Now, I'll say, generally, different people have very strong opinions about style and data visualization. In fact, data visualization is its own field. It's a rich and complex area to study, and it's quite candidly beyond the sort of introductory course that I'm able to teach you here. However, I will point out a couple of things. So you can put this plus at a couple of different places within the GGplot line or the GGplot code. I want you to get used to taking a single space, adding a plus, and then hit enter, and we're going to then continue writing the code underneath it. So always end your pluses or end your line with a plus. Now, if you, just like we talked about yesterday, if we end our pipe with a pipe, then we noticed that R was going to be looking for more information. We say we find our keys and then go to work. And if we put an and then, if we put a pipe on the end of that trivial example, the R is going to then say, well, and then what? What do you do after you go to work? So we want to make sure that there's not the pipe on the end of a string of functions. Similarly, we want to make sure there's not a plus on the end of a ggplot construction. If we have a plus, then ggplot is going to say, I'm going to take my data, I'm going to add another layer, which is maybe my geom point. I'm going to add some labels, I'm going to add some other information. And if you end that last line with a plus, then it's going to say, what else do I add? So we need to make sure that our very last line doesn't have the plus, but as we add these layers, we add, and we always put that at the end of the line. Also, I just showed you an example where I had a line of code and it said ggplot, and it said data equals heart plus geom point mapping equals AES x equals y equals and so on. Now, it turns out that those are arguments, and those arguments within the ggplot code don't need to be specific. There are default positions for this different information, and ggplot then is expecting a certain type of information in that position. So for example, if you say ggplot heart, just like I show you at the bottom of the screen here, and you don't say data equals heart, that's okay, because ggplot knows that this is the type of information I expect in this position. I'm expecting some type of data frame. The data frame is an object, and if you just put it here, I know that that's the data. Similarly, I know that within the geom, I'm expecting some mapping data. So you don't need to tell me it's mapping, because that is what I expect in this position. Now, if you have some non-standard types of data, and we'll get into what I mean by that a little bit later, but if you have some different types of data in different places, you want to be very explicit, because ggplot then needs to know to do something different. But for the most part, for a very simple data visualizations, we can use the shorthand ggplot, we put the name of our data frame plus our geom, and then our aesthetic x and y. And so this now, if you want to update some notes on your template, this is the template that we want to use when constructing our ggplot visualizations. Now, if we just sort of take a very simple question and we say, I ask you, how are these two plots similar? We could find a couple of things that are similar between them. If you want to go ahead and light up the comment board, if you see some things that are similar, go ahead and do that now. And I'll just give you a second to inspect these plots. I'll give you sort of a heads up or a clue. I will also ask in just a minute, how are these plots different? But let's look and see how they're similar first. So go ahead. So we can see that the axes are the same. We can see the age is the same. It's on the same scale. We can also see that the y-axis is the same. This is this THALACH, not quite intuitive, but apparently a descriptive variable for some people. This is this heart rate value. We can see that not only are the axes the same, but the scales are the same, so that's important. We can see that there's also sort of Man of Steel 13 says there's a general downward trend as heart rate as age increases. That's true. And so we can see that I'll sort of give you the spoiler or give you the answer. It turns out that these plots, these two plots here, are the exact same data. It's the exact same data, and it's going to be nearly exactly the same code. So here, what we look at is the two different plots. Plot one is the one on the left. That was our scatter point, and our plot on the right is going to be our different plot. So it turns out that these are very, very similar plots. And the only thing that's different is going to be the geom. So the geom on the left here is going to be a geom point, and the geom on the right is something called geom smooth. Now, this is amazing because what we can do by just changing one small part of the code is we can now change the type of visualization. And what we have here is the geom smooth fits a regression to the, I'm not sure if this was a linear regression. In most cases, you have to specifically define the type of model you want to fit to your data. If you don't, it will then guess the best fit. And so now what we have here in one line of code is a simple regression model assessing the data or looking at the raw data itself. And in fact, we'll show you this in just a minute, but you can start to build some complex plots where we have both types of genomes on the same plot. And so this is pretty powerful, and this is where you can start to get a sense of the power of this GGplot, where we have very small changes can help us visualize complex data in different ways. So now, one of the things that we learned about yesterday was called glimpse. And so remember, if we want to take a glimpse at our data, this is going to then allow us to visualize the different attributes of our data frame. So go ahead on your own and just type in glimpse heart in that code chunk, and you should be able to then see some of the heart like this, and you should be able to then see some of the attributes of this data frame. So this is the same one as yesterday. Again, we have a patient ID that we essentially use just as a number. We'll get to why we did that a little bit later today. But then you can also see age, sex, CP, TRES, BPS, cholesterol, FBS, and so on. If you want to learn more about what those, the data dictionary and what those specific variables are, you can go to, again, this is github.com/MatthewHershey/Tidybiology-+DS. There's one other actually way, if you guys have a hard time seeing this URL on the screen, one thing that you can do is within your RStudio Cloud, let me just launch it here, the project. So you guys mostly are looking at this project right now. As soon as this opens, I'll show you, there's one other place that you can look at the data dictionary, which is in the README file. So this is the README for the class. It's called readme.markdown. And as soon as that opens, if you go to project, so some people got quite deep into the directory subfolders yesterday. It might not be intuitive, but these words here, this says cloud, this says project, and this says code. And all of these, let me see if I can go like, I can put a box around them. So I don't know if you guys can see that box or not, but these, but right here, these are actually links that can then get you into different directories. So if you click on project, and then you click on the readme.rmd, what you can see is the specific values of the data dictionary. So this is exactly the file that you see on that GitHub site. So if you want to then learn more about what these different variables are, that's where all the information is. But so recall now that we use glimpse to look at this, and this will be important because if we're thinking about different plotting and different types of plots that we can construct, it turns out that the different types of variables are going to be plotted in different ways. So I'll just type that again as an example. If we have here, so let's say, for example, we have sex, and this is a character variable, and we have two different options. We have male and we have female in this case. And so we know that we don't want to try to plot a character variable by a character variable, or the way that we are going to then handle numeric variables versus non-numeric variables will then determine the different types of data that we can make. And so knowing the type of variable, knowing the range of the data, again, this comes back to just knowing your data is going to be very important for making effective visualizations. So one of the first things that you should do, and we have a couple of code chunks in the exercises today for you, is taking a glimpse at your data frame to remind yourself what you're looking at. And if you want to look at something else, then you can look and see what variables are available. All right. Now, so if you know what variable types, how do you know what genomes are available to use? So there's several resources, and we'll just point you to two of them that can match your data type to the appropriate genome. So the first one is, again, this RStudio cheat sheet. So we talked about the cheat sheets yesterday, and there was a cheat sheet for dplyr that we showed you. There's also a great cheat sheet for the visualization. And so here, data visualization cheat sheet. So you can download this, and this will be a great way for you to see what GMs are available. What you can also do, if you recall, is there's a cheat sheet link within RStudio Cloud that then gets you right to that. So you don't need to Google it, or you don't need to go to a specific site. Like that will link you straight to the cheat sheets. And they update these cheat sheets from time to time when they have new functions as the packages are updated. And so this will then be the link to the most recent cheat sheet. So within there, what you can do is you can see that there are several different types of genomes based on the data, and it tries to the cheat sheet tries to guide you whether or not you have a categorical variable, whether you have continuous or discrete, whether you have one variable versus two, and so on. And so that's a nice help. So again, there's a hyperlink here, or there's a link within the RStudio Cloud. Also, there's this great website called data2viz, so data-2-viz.com. And this website is all things data visualization. And what you can do is it allows you to explore a lot of different types of plots. But then here, it helps you make some decisions about the appropriate geom to use for your data type. So this is great if you have a numeric, a categorical, if you have numeric and categorical, if you're trying to make a map, network, time series, and so on. And so they have essentially a decision tree down here, one numeric variable, histograms or density plots, two numeric, ordered, not ordered, and so on. So you can take a look at this site sometime and really spend hours looking at it. But this is going to be a good resource to help you understand what types of plots you make for your data. So it turns out that you don't just make a plot for all data types. We need to think about the data we have. We start thinking about the information that we want to convey, and then we can start using the appropriate visualization tool. So again, this is data-2-viz.com that is really just an amazing labor of love for a couple of people that have put this together. So you can read all about that on that website. All right, now, so this is a challenge for you guys. Go ahead and take 2 minutes to try to figure this out. So what I want you to do is I want you to change this scatter plot to draw a box plot. So here's the code here. If we take this code and we run it here, what we should be able to do is see that this is going to make a scatter plot. This isn't that informative. It's as uninformative as the one that I showed you before, which was looking at sex and cholesterol levels. So here is sex versus age. We'll go ahead, I'll put on the 2-minute timer and have you guys try to use some resources. So I just showed you a couple of resources that you could potentially use in order to find this. So I'll put on the 2-minute timer and go ahead. All right, welcome back. So we chose a box plot because this one is actually quite intuitive. If you take geom and you type in geom box plot, what you can do then, just like we had the geom smooth versus the geom point, you can change the visualization tool with just this change. So I'm curious about how many people were able to do it. When I say use your resources, again, I just put a pro tip up there. Google's a good point to start. You could go to the cheat sheet and look there. You could go to a Stack Overflow and these sorts of things. But essentially, if you Google, how do I make a box plot in GGplot2, this is what you will see. Now, it turns out that there are several different ways to make box plots. Yesterday, we talked a little bit about base R versus the packages. There are some rudimentary visualization tools in base R. So if you typed into Google, how do I make a box plot in R? You might get a different answer than if you type in, how do I make a box plot in GGplot? And so you want to make sure to be very specific about what you're trying to do because you will get several different answers depending on that. So so this one is quite intuitive, quite simple. We have the same sort of setup. Again, this is the very sort of familiar now a template where we have a GGplot, our data set, plus geom point, our aesthetic. We want to compare sex versus age. Okay. Now, if we look at this, and we would say, what does this code do? What would you predict? We have, just a chance to use the chat board or to think, to turn to your kid who's pulling on your leg or your cat who's walking on your keyboard or whatever. But let's take a look at this. We'd say, well, what do we think that it does? Well, let's go ahead and try it. So we take this, we can copy and paste it, or we can write it in. Some people, when they're teaching this course, they feel strongly about typing it in. I do think it's important to type things in and to learn this sort of syntax. In fact, because I have oftentimes cut and paste errors. But at this point, I'll leave it up to you if you want to cut and paste, if you want to try to type. So what we can do is if we run this now, what we can see is that this is a way to add 2 geoms to a single plot. So that's exactly what this does here. If we take this, so looks like Amy nailed it. Nice work, Amy. If we take this and we move it to here, don't forget the plus, then what happens is we get the same thing, but it looks a little bit different. So the order that these are added is going to be very important. It's going to start with the data, and I'm going to add a geom point, and I'm going to add a box plot on top of that. So that's why we need to make sure that if we want to layer multiple plots, then we would see something. We need to think about what we want to see. Do we want to see all the points? Do we not want to make all of the points? So that's going to be an important consideration. But the nice thing is we can start adding several different types of layers now to make more and more complex. But it's not just about complexity. It's also more and more rich plot with more information. When we have just our box plot like this, what we don't have a sense for is how many points are here. Is this a lot of points? Is it a few points? Where we can get the box plot's great because it gives us some summary statistics. But sometimes it's also nice just to see the raw data. So up until this point, everything that we've done so far is it just gives us a basic graph. But now we can start to think about colors, shapes, and overall style. So again, if we think about this sort of world of data visualization and a world of strong opinions, what we'll find is that some people will say, well, we don't need color, we don't need anything fancy, we don't need to sort of muck up an otherwise very clean, simple, and informative plot. But if we stop for a moment and think, beyond just an X and Y axis, we have variables that can encode more information. So we can encode information in color. Sure, we could just make our plot blue because my favorite color is blue, but we could also then encode some range of colors on a scale and have that color information there. We can encode information in size. We have these different variables. And so what I want you to do now is take a few minutes and go to the code folder. And this is going to be the first time that we're going to sort of deviate from the slides. And I want you to open up the GGplot lecture. So this is 04 GGplot2 RMD and complete the exercise. So again, where you'll find that is if you come over here to GGplot, this is essentially like a browser that has different tabs. So we're working on this plus DS session 2 today. If you click on project, you'll see the code folder. Click on the code folder here, and what you'll see is the 04 GGplot RMD, and that's the one that I want you to open. So if you click on this, it should open up in a new file here. Again, remember, if you want to get back to the session file, it's just going to be in this tab right next to it, which is the slides. So here what we have now is the RMD that I want you to work through. So just go ahead and take a look at this. What I want you to do is when you get to this, I want you to run each of these code chunks. And remember, to run a current chunk, you just hit this green button here. So this is going to run it. We're going to run this one. This loads the data. Don't worry about what's happening in this. It's there's a handful of things that are happening, but we just try to make it easy for you. So we wrote a little script that loads the data. And then start with this third code chunk, which is take a glimpse of the data. And then we're going to think about some mappings and some different aesthetics. And I wrote some template code for you here. So let's go ahead and just take, I'll put the 2-minute timer on again. And just see if you can work through these by changing these different aesthetics, by changing color, size, shape, and so on. So again, if you have questions, go ahead and light up the question board, and we'll go ahead and start that timer now. All right, how'd that go? Go ahead and give me a thumbs up if you got through that, if you made it through, and if you need a little bit more time, just go ahead and shout out more time or give me an emoji that lets me know that. So go ahead and let me know that now. And really what we want to do is just sort of get you guys comfortable with this idea of our Markdown document as we worked on yesterday. Let's see, and then also to start working in these code chunks and start changing some of these variables or these sort of different a different function. So we've got a couple of questions coming in. So let's see. Getting error. Could not find function geom. Okay, so we've got two of these. I'll just pop crystals up here where we couldn't find geom. So remember that geom is just the generic. There's no geom that's just called geom. So what you need to do is we need to specify geom. So geom should always be followed by geom underscore and then the specific geom. So make sure that you're doing that and not just writing geom. Geom was just part of that template, just like the data frame name is part of this template that I wanted to have for you. So let's see, a couple of people say they need more time. That's all right. We'll go ahead and just answer some more of these questions. We're getting the horns of rock, thumbs up, okay. Yep, let's see. We have one, Akshay Barajas says, could we wait 2 more minutes? Akshay, yeah, if you need some time to work through it, it's fine. All right, so go ahead and while you're working through it, I can go ahead and look at some of these examples here. So what we would first do is we do something like this. Actually, let me look and see. I don't know. No. So what we have here is we would take a glimpse into the heart data set and just get some information about it. And this is going to, let's see, we'll run this, and then we'll glimpse into heart, include equals false. Okay, let's get rid of that. I don't know why that's there. If you weren't able to glimpse into heart, get rid of that part that I just did. That shouldn't be there. So, okay, so this gives us a glimpse into the data. Okay, I don't know if any of you also had that problem. Let's see. Denise is asking, does a RMD for session 2 only have 36? Denise, what you should do is just do this right here. What you want to do is just make sure you do something. You just come up to this top right-hand panel, click on the Git tab, and then just type do pull. You might have downloaded an early version when we didn't have all of the slides finished and all the material finished. So just do that, and you should pull in all of that information. Okay, so back to here, we glimpse heart, we see all of the variables, and then this is, again, just our generic, but again, this geom, what we should do is geom name. It should look like something more like this. And so take a moment of this to make a simple ggplot. So ggplot heart plus geom point, and then x equals age, y equals, let's say, cholesterol. And we get something like that. So we have a relationship or sort of the plot of age versus cholesterol. And then we can start changing some things. So I'm going to cut and paste a little bit here. So we can just do a little bit of live coding. So then here what we're going to do is we type in color equals blue and see what that looks like. Okay, let's make it a little bit more bright. Nope, that's a red. Red will work. Okay, there we go. So we can see that now. We have these points, and we're basically just coloring them red. Now we can come in here, and it says retype or paste the code. Okay, and then add a size aesthetic. In the template, it goes the same place as color. So if we say size equals, let's say 10, see what happens there. Oh, I have an extra period there. Okay, whoa, okay. So what we can do is we can change the size now of these points, and that's going to be quite ridiculous. And so if we go maybe 2, let's go 1. Okay, that's much, much smaller. And so again, kind of depending on what our goals are for the visualization that we're trying to make, we can change size. So then shape, what we can do is we can also say shape and equals, let's say 6. So these shape, at that link here, there's different line types that have different shapes. And so these now have a code. I think there's like 20, maybe 23 of them or so, where you can then have an X or a circle or a square, a filled, all of these sorts of things. And the shape can change again, depending on what you're trying to do. So alpha is an important one. So alpha, let's go like this, size equals 10. And we have those big giant ones, but we can say alpha equals 0.2. So what that does is it makes it much more opaque. And so this is an opacity value between 0 and 1. And so 1 is 100% filled, and 0.5 would be 50%, and so on. It turns out it's not exactly percent, but for our purposes here, you can think of it that way. And so again, what we can do is if we put size equals 3, make them a little, size equals 3, I forgot my comma here. What we can see is that there are some points that are overlapping, and that might not have been obvious if we didn't have this alpha. So this is important. What we have is some people of the same age that have the exact same cholesterol levels or nearly overlapping cholesterol levels. So, all right, and the last thing is to say fill, and then let's go fill equals blue. Okay, in this case, the geom point doesn't actually use fill. The different geoms are going to use fill differently. So if we have a different geom, we'll talk a little bit more about fill versus color, but essentially fill is going to change. Let's go size equals 10, just make sure that's right. Yeah, so fill is going to be used for some geoms, color is going to be used for other geoms. So so that's the simple exercise that I wanted to sort of walk through with you guys, just to get a sense for how we can change these. And again, all of this is by looking at this simple code, X and Y aesthetic, and then outside of this parentheses, we put a comma and a color or aesthetic or size or so on. Okay. So now let's go back to here. Everybody should be done with that now, and we can move on. So now there's this powerful ability simply beyond changing the size or the color of the variables in your plot that I mentioned before, is where we can encode more information into our plot. So as one example, we could think of a variable that might be important in this case. And so one that comes to mind is, let's say, sex. So if we wanted to compare, like in that age plot, the males versus females, we can then use that color as a way to encode those different variables. So here's another example. We'll give you guys 2 minutes again and then check in and see if you need a little bit more time. So what I'd like you to do is go to the code folder and then open up the exercise 5 and complete that exercise. So again, in the same folder, you just completed exercise 4. Then go ahead and fill to complete exercise 5. All right. So I will start the timer, and you guys can go. All right, welcome back. So let's again light up the comment board. If you need more time, let me know. If you made it through, that's fine too. So the major difference here between the last exercise and this exercise is the idea that we can use the aesthetic where we normally have X and Y variables. We can start including some other variables within that aesthetic, and that's how we then encode more information into our plot. So as an example, I'll just walk through this with you here. So we're looking at this 0.5 AES exercise, and we again glimpse. We just did this so we know what we're sort of looking at, but for completeness, again, I have to fix this, include false. That shouldn't be there. We can then we should take a glimpse at it. Okay, now we had some code. This was our code that we had before. We run it. It's some pretty basic code. Now what I want you to do is compare these two plots. So for the plot on the left, that's the one that I showed you. We have age, and we have cholesterol, and then we have a blue because I like blue. What we have on the right, though, is again this age and sex, or sorry, age versus cholesterol. But we have now is color is on the inside of this aesthetic. So if you remember back to when I told you about mapping different variables, and we use mapping equals aesthetic and everything inside that aesthetic. Well, this idea of mapping a variable to some, like in the data, to a visualization tool is exactly why we call it mapping. So in this case, what we do is when we have color outside of this aesthetic mapping, we're just forcing the color to be something. Maybe because it's our favorite color, maybe because it's some branding thing, or because it's Duke Blue, or because whatever. What we have now, though, is a more powerful way to encode a variable onto color, and that's by this code here for plot 2. Now, importantly, what you'll see is that there's two major differences that I want you to notice. So the first is that color is on the inside of the aesthetic in the second plot. Okay, so if we want to map it to a variable to a data element, what we need is to put it on inside of that parentheses. But the second thing is this color is equal to an object, and that object then now doesn't have quotes. And that's why in this case sex doesn't have quotes. If we put sex in quotes, then and run this, then what we would have is, let's see, let's run all of this now. What we would have is this arbitrary color, and this arbitrary color then is mapped to a variable that doesn't exist. And so what we want to do is something like this, where this is an object. This is a variable within our data frame, and that is unquoted, and that's how we get that color. Now, we do have the power to change this color later, so don't worry about doing that right now. So if we wanted, pink and blue, or if we wanted some colors that are colorblind friendly, or these things, we can absolutely change that. But the important thing before we start changing the sort of look and feel and touch of our visualization, what we want to do is we want to nail the data. We want to say, okay, if we want to then compare the male versus female within this data set and who is who on this graph, this is how we would do it. Okay, so what then I asked you to do is you can use some of these aesthetics mapping these to variables. So if you want, then you can play with it, and that's what I was hoping that you would do, is if you take this here, this code, and we can then, instead of saying color equals sex, we can say, let's see, size equals sex. And so we have large and small. This isn't really that informative, but it's possible. And again, it kind of depending on the data, we would map it differently. but this is just to play with and just to see what's possible. So we can also do shape. So we have circles versus triangles. Again, that's not really visually that informative, but so you get the sense. All right, so then that's a really important idea, is where within this aesthetic, we have X variables, we have Y variables, but we also have this other a toolkit, which is here, where we've got some color, size, shape, and fill that we can map to our variables. Okay, so I'll just take a moment here and check the question board to see if anybody's having any questions, about some of this. There's a couple of technical things that people are still trying to figure out. Let's see. The code is executed, but the graph is blank. All right, so Akshay and Ali are working on this. Just let me know if you have any. Yeah, so we have one question saying fill variable seems to not work. Again, fill is going to be specific for some data types versus others. We'll get into fill. When we start looking at histograms, fill is a good way to look at the fill color of our histogram. So don't worry about fill for now. Fill will work on some GMs, but not others. All right, so now this idea of global versus local. So this is the next sort of big idea that I want to share with you. So in GGplot2, we have the option to set mappings globally or locally. And so what that means is that you can define where your data are called in different places. So as one example, let's say that we have a plot that looks like this. So we had GM point. GM jitter is similar to GM point. It just is going to add a little bit of noise to the data to make it not overlap. It's a great little GM that you should be familiar with. And so we can take our GM jitter, GM point, and we'll look at sex versus age, and then we can put a box plot on top of that. So the way that we did that is we said we've got our heart data because that's where we define our data. And then we add, with the plus sign, our GM, and then our aesthetic is sex and age, and then our GM box plot, sex and age again. However, this would be defined or described as defining our variables locally, which means that we define our aesthetics, we map our aesthetics at each GM. There's another way to do that, which is, so this is what we see, okay? There's another way to do that, which is to map our X and Y values in the GGplot function, which we would sort of define as globally mapping these. And so with everything down below, all of these GMs are going to inherit the same data and the same aesthetics, the same aesthetic mappings. Then it's much more efficient and simpler just to say GGplot heart, that's our data. The aesthetic is sex and age. And that then sets up everything for us to then handle later on. So we have GM jitter and GM box plot or GM point or whatever we're using. So this is nice because it's defining everything sort of at the global level. And then down below, we can then make it much more clear and have a little bit more concise code rather than repeating it. So exact same idea, exact same concept. It's just now a little bit simpler where we sort of define it globally and everything that we add below is going to inherit this information. Okay, so this is just writing out what I just said is that you're setting the aesthetic globally and everything inherits it down below. The converse or the flip side is this local. The reason that we would want to do this now, though, is because we can start then to very specifically define what is the globally going to be inherited and applies to all of the elements and what now is going to be specifically inherited. So look at this plot and let's think about this for a moment. We'll spend some time here. If you have questions, again, just light up the question board there. So we start out with our code that says GGplot heart. All right, you're all with me so far. And then we say our aesthetic is going to map to sex and age just like it has for a while. We add now a layer of GM jitter. GM jitter is going to be just like GM point, but what it does is it spreads it out and adds a little bit of noise so we can see all of our data much better. We talked about how before there was a lot of overlap and it was much harder to see. In this case, GM jitter is going to correct that problem. Now we have GM box plot, and we had that before, but in this case, GM box plot is going to add a little bit of color, but it's going to add color to only the box plot. Now, if we had added the color mapping aesthetic at the global level instead of the local level, then what would you anticipate the behavior be? What would the plot look like? In fact, if you have your RStudio Cloud open, you can just go down to the console and try it, and look and see and play and figure out what's going to happen. So if any of you are doing that, what you would see is that that both the points and the box plot are going to inherit the color. Now, if we wanted to map a different aesthetic to GM jitter, we could do that too, and so on. So what you can do now is you can start to specifically determine and decide on how this behaves. If everything being colorful is going to be too busy or too much information or whatever you decide for your visualization, you have the power then to say, I want everything to look like this, and I want some things to look like that. And so you can start to see now how these layers are going to add up. Okay. This continuum, this concept of global versus local, data can also be set locally or globally. So as an example, we're going to use one of the functions that we talked about yesterday, which is filter. And we're going to filter our original graph using this dplyr filter function. This notation here, you might see a few times where you have the package name and then colon, and then the function name. This is just going to be a very specific way to say, I'm talking about the filter function within the dplyr package. Now, unfortunately, there are some packages that use the same function name as other packages. I told you there are thousands and thousands of packages on this CRAN repository. So what that means is some of these will be reused. And in some cases, what you need to do is be very explicit. And this is also the way that you can be explicit about which function and which package you want to use. But in most cases, this is just to remind you and to remind me that this is going to be a function within the dplyr package. All right, now, so what we can do is we can say, we've got a data set here, and let's say that we want to look at this heart rate, and this heart rate level is only, this is this maximum heart rate under an exercise stress. We want the values that are only over 195, okay? So these are the patients within this population that can get their maximum heart rate over 195. That's either very fit people or young people or both. And so what we can then do is we can say heart and then filter this variable greater than 195. And we can then assign this to a new data frame. We'll just call it, for this example, a data frame filter. All right, now what we can do is, I just also mentioned, I came up with that number because that's 2 standard deviations above the mean value of this variable. And so like these would be considered like the outliers in the population that have this elevated heart rate. All right, now what we can do is we can identify the patients in this data that are outliers that have more than 2 standard deviations above the mean by setting data locally in a new geom. So this is what it might look like. We'll take it one line at a time. So we start out with GGplot. We then say we're using the heart data set. We then are going to map our aesthetic of sex and age, just like we did before. And then we're going to have a GM jitter and a GM box plot, and then we're going to set color here for our sex variable. So this is exactly going to be that box plot, that jitter box plot that I showed you before. And because we're setting color, we're mapping this color variable to sex only in the box plot. The box plot will be colored, but not these data points. Now what we can do is we can label, and this is actually another geom label. We can label some of these people that have this outlier heart rate, and we can see where they fall. And in this case, what we can do is within this, so this is going to be a global mapping. This is a local mapping of an aesthetic. In this case, it's our color. We can also then locally map data. So we can add a label. The label is going to only be using that filtered data. And then what we can do is the way that you define this aesthetic is you say what do you want to label this with? And so we can then say we're going to label our patient IDs. And this is what it looks like. So we end up with something like this, where we've got our box plot on the left, our box plot on the right, our distribution of age and sex, and then we say, well, there's some outliers that have this very high heart rate, and then we look and we can see that there are a handful of young and apparently very fit males that have IDs 61, 65, 119 and 669 that are in this. So this is a quite arbitrary example, but what I want to show you is how you can then take, we'll go back and look at this code one more time, where you can take and start defining data at different places and start defining these aesthetic mappings at different places and different levels to get the type of information, the visualization that you're trying to achieve. Okay. Now, so you may notice we have to indicate the new data set because it has the same name of X and Y values, but we didn't need to set those mappings. So if we come back here, we can say that the data is here, okay, and this data frame has a new name. But the aesthetic values, normally this would also look for X and Y. It would need some X and Y, but the X and Y is here. So again, because we didn't reset X and Y, it would inherit this X and Y value. Now, if we write X and Y, it would be redundant and it would also look exactly the same. But that's maybe you're curious why we don't have an X and Y in there, and that's the case. So let's go ahead now, another opportunity to practice this global versus local. So now what I want you to do is open up exercise number 6, global versus local. So we can come back over here, we can close number 5, we can open number 6, and then go ahead and work through these activities. And I'll go ahead and put on our lovely background music to help us focus. So go ahead, ask questions if you have them. All right, welcome back. So that was just a sort of cute little example to take some of the code that you've been working with already and try to change, to add another a layer if you haven't done that yet, and then to change that from a local variable to a global variable just to give you a sense of how that works. So if you have any questions, you might not need more time. It was a short activity, but if you have any questions, go ahead and ask them now. So what I want to do now, though, is to move on. I introduced you just very briefly to some labels and how we can put some labels using GMLabel right on our plot. But we also have some options to change default labels and legends and so on. So if we just take this code again, we've seen it a few times now, where we're looking at just the relationship between sex and age in this data set. We can then start to think about this is what it looks like. But we can identify a couple of problems with this already, where there's two problems, and I've highlighted them here. The first one that I identify is that the x-axis label is redundant. So we see that this is sex here, But we really don't need this to say sex because this is pretty much obvious from having male versus female. And so this really doesn't add that much more information. I would say keeping age on here does add more information, so we wouldn't want to take that one off. So we would maybe want to take off this label because it doesn't really add anything. The figure legend in this case is also redundant, so it doesn't really help us that we're mapping male and female to these colors because we can see that here. So what we want to do now is we want to explore how we can start to modify some of these attributes of our visualization that end up being a little bit redundant, or if we needed to change them for other reasons. So the first thing we can do is we can change labels. Labels has a layer, just like the rest of the layers within GGplot. And this layer is called labs, labs short for labels. And what we can do is we can then use this labs and we can set x equal to, and if we put in a quote, so normally this is going to expect a string. And so we're going to put in quotes if we wanted to change our label, if we wanted to capitalize it or change it to something much more informative or intuitive, we would put that string in here. It turns out, though, if you include nothing in between those quotes, then that string is blank, and that's a very easy way to then just remove that x-axis label. So these blank quotes removes a label. Anything in between the quotes would go there. So if we do that, what we see is that code now gives us this plot, where we have removed what formerly said sex down here at the bottom. That's now gone. So the other thing we want to do is we said we wanted to remove this guide over here, this figure legend. So the way that we do this is with another layer. This is called guides, and we can change several aspects or attributes of guides. But the way that we want to change this one is going to be by setting the guide for color equal to none. Now, the reason that we say color equals none is because the guide is telling us about the color. It's mapping color to sex. So if we had another, let's say size, and we said size was sex, if we wanted then to get rid of that same figure legend because it was redundant, what we could do is we could then say guides size equals none. So the reason it says color is because that's the guide for the aesthetic that by default appears that we want to remove. So if we now have this code, it's going to give us this here on the right. So what I've done is I've actually taken now on the left is the original code, and on the right is the updated plot. So we have sex and we have a figure legend here. So if we take this off, we can see that we no longer have that redundant x-axis. We also don't have the redundant figure legend. So there's, again, a treasure trove of functions and layers that we can add to our visualizations. And this is really just giving you a sense of how to do some of these. Okay. The next thing I want to describe or to tell you about is probably one of the most popular and simple things to do within the exploratory data analysis for data visualization, and that is called faceting. So faceting allows us to create multiple graphs, side by side or top and bottom in one panel. And this is really useful for exploratory data analysis when we want to look at data together, but not on top of each other. So what does that look like? If we take this example, so we first, again, we're trying to use the same example that we've used a few times now, just for consistency. So now you can anticipate what this looks like. We've got a geom or GGplot heart, and now we've got a geom point, and we're looking at sex versus age. We've done this a few times now. This is now just going to be point. It's not going to be our jitter, and it's not going to be our box plot, so we're just looking at this point. But what we can do is we can use another layer, and this is called facet grid. And facet grid is then going to expect a couple of arguments. So if we come over here into RStudio Cloud, and we go to this Help tab, so in this lower right-hand side, I just clicked on this Help tab. If we type in facet grid, what we can do is we can get information. This is the help page for this function within GGplot2, just like it says here. And so it can tell us the type of information that it's expecting. And what it's also telling us is the default. So here, facet grid, the default, these are the defaults. So if we want to change the default, we have to change that. So if we go back to our example, we say facet grid. Our columns is going to be a variable called FBS. FBS in this case is fasting blood sugar. So when these patients were admitted, they had been fasting and their blood sugar was taken and they have a fasting blood sugar level. So what we want to do is we want to then compare our patients for this plot by sex versus age for those that are stratified by fasting blood sugar. Now, our fasting blood sugar has two levels. It has elevated and it has normal. And what we can do now is we can then facet based on whether or not we have patients that are elevated and patients that are normal. So let's say we wanted a sense of our patients in this population, and we wanted to make sure that we had a roughly even distribution of patients by age and sex for elevated versus normal fasting blood sugar. And we can see that generally it's about the same. We have fewer younger people that have elevated fasting blood glucose levels, but maybe that's to be expected. So what we did essentially in adding one line of code is we now took one plot that was combined and we separated it, we faceted it, and now made two plots based on the elevated versus normal blood sugar. The reason that these come side by side is because we identified back in this code here that these are columns. So columns equals a variable like fasting blood sugar. All right, now, again, I'm just giving you like the briefest introduction to some things that are possible. And I'm not expecting everybody to memorize every single one of these functions. But remember, this is a new foreign language for all of us. And there are new functions that are added as packages are matured and developed. And so I am learning these new packages in this new language along with you. And so what we oftentimes do is we use this help page. And what we can see is if this is a facet grid, what's expecting is expecting some rows or columns, and then it's expecting a set of variables quoted by vars. So that's how we know that vars is expecting something on the inside of it. And we come here and we say vars is expecting a variable. In this case, we choose the variable, and that's what it looks like. All right. Now, before we get to themes, faceting is sometimes a topic that leaves people a little bit sort of furrowed brow and not quite sure. And so go ahead and take a moment and ask questions, or if you want me to reiterate something or show something or explain something a little bit more. There's no way that I expect you guys to just know this. In fact, when I was preparing some of these new slides for you guys for this lecture, I had to go to the help page to look to see, okay, what is facet grid expecting? How does that work? So we've got one a question that just came up. What happens if we use facet grid with a numeric variable instead of a categorical? Is it an error? So that's a really good question. What we could do is I would say is let's just try it together. So what we can do is we can take this code here and let's just copy it and come over here and open up the console and copy and paste. Let me go like this. And hopefully what you see, let me actually try this again. I'm getting rid of all of that. And so what you see now over here in the plots tab on the lower right-hand side is the plot that we just made. So if we want to plot this based on a numeric, so if we glimpse heart, we can see we're comparing age and sex, and let's go back to cholesterol. So we then go like this. Oh. What this will probably do is it will probably crash it. So let's see. Because what it's trying to do is it's trying to have the number. Oh, it didn't crash it. That's good. So what you can see here, maybe, is quite small. If we then ask how many unique values of cholesterol there are, I think there's a function called unique. So extract unique elements. See, Ali or Akshay, you guys should throw out a comment. Do you remember, if we take unique returns a vector, but with duplicate elements rows removed. So let's go like this. Let's go length. L-E-N-G-T, length, unique, heart, cholesterol. So what this is doing is it's omitting any duplicate values within this heart cholesterol. And then length is just like how long is that vector. So it's 152. So, yep, thanks, Akshay. So what I was able to do then is I was able to make 152 tiny, tiny, tiny plots that were all next to each other. This, in some cases, this might crash your computer. This is our Studio Cloud, so we probably have more resources. If I ran this locally, it might just hang or something. What you want to do, though, is usually you want to have a factor or a categorical variable, something that you would say, well, I want to compare, like, here's our fasting blood sugar, and you can see that this line right here, it's normal or it's elevated, and this is what we compare it on. So we can do the same thing if we look at something that's numeric, but it only has zeros or ones. And so let's say target whether or not these patients ended up having heart disease or not, and we can say that these are 0. So we know, so this is encoded as a numeric, but we know this is actually a variable that's going to be only 0 or 1. And so again, we can stratify, or we can facet based on this. So that's a great question. So any other questions before we move on? Go ahead and ask them now. All right. So one of the last things that we're going to get into with the GGplot are themes. And so themes are a way now where we can start to modulate the different elements of our visualization. And this is going to be for much more aesthetic purposes. And what I mean by that is a look and feel and touch of the visualization that we're trying to make. So fortunately, you can change almost anything you see on your visualization. And there's different ways to do this. So the interesting and honestly kind of complicated thing about themes is that there are several different ways to change different elements of our plot. And so I'm going to show you just a couple here. So what we're going to do first is we're going to change some of the features around our title text. All right, so we've seen this code before: GGplot, heart, sex, age, jitter, box plot, and so on. And then we have a title called My First Plot. Okay, so labs, we talked about how labs can change your X or Y variable. Labs also has a variable an argument called title, which is where you can change or add a title to your plot. So in this case, we're going to say it's My First Plot. And then what we're going to do is we're going to use theme, and this is where we're going to start being specific. So we say theme, and it's expecting an argument, and this argument here is going to be plot title. And then we can say we're going to change the text of that title, and we're going to change it by making it bold and making it a different size. So what does that look like? Well, we can then say on the left is our original code, and on the right we can see that this is going to be now a title. We added it, but this is going to be bold, and it's going to be of a specific size. So we can start to say we can start to change some other things. So remember we had this legend box. So we're now adding a new line of code. This is the one I just showed you. But for example, let's say we have a legend and we want to start changing some elements of the legend. So we see the first thing that we change is plot title equals this. What you can see now is all of this code is a single line that is going to be then separated by a comma, and then this is going to be its own line, also separated by a comma. One of the things that you want to be aware of and keep track of are your commas and your parentheses in R. And so our theme has to be wrapped in parentheses, just like our labs is wrapped in parentheses, just like our genomes are wrapped in parentheses. So we want to make sure that this final parentheses is on the end here. R will probably scream and yell and complain if you don't have it on there. And but what we can see is now we're changing the legend background. What are we changing? We're changing not the text, but we're changing the rectangle, which is around it. We're going to fill it up with gray, and we're going to give the color black. So what does that look like now? Well, again, the plot that we just made is on the left, and now our new plot here is on the right. We're going to say this was not nearly obtrusive enough. We need this much more sort of dark and obvious because we want to draw attention to it, or something like this. All right, moving along. So we can start to see we can build these up. So let's change the legend position. So now we started with this. We added a title. We changed the title face. We changed the background. But what we can also see is, in this case, we're changing not the legend background, but the last line here is going to be changing the legend position. We can say we want it on the bottom. What does that look like now? Well, we can see that this was the former plot. Now we put this on the bottom, and we can again start to change all of these elements. And so there are highly detailed help pages that sort of guide you through this. Also, Google, Stack Overflow, all of these different resources. So nobody, just to make it exceedingly clear, like nobody just knows how to change the position or the color of your legends, right? Everybody is looking this up all the time. And so when I'm writing a code, I will absolutely be looking at the help pages. What does it expect? What order? What have other people sort of done, figured out, and so on. So there are tremendous resources out there. Okay, so we've got one question that just came in. We said, how do you know where to put the space or underscore between commands while writing code? The space or underscore. So sometimes spaces and underscores matter, and sometimes they don't. So, so for example, if we come here, nope, not there. So let's say if we come here, there are some places where we can't have a space. So in this case, this is the name of the function, like geom_point or facet grid or these, like you can't have a space here, just as Ali is saying, is because it needs to recognize this as a function. If there's a space, then it will recognize it as an object, right? We need our parentheses right next to it. So in most cases, there's no space. In some cases, if we look at this last code that I wrote here for this, GGplot heart, geom_point, sex, age, and then we faceted, we'll just fasten the fasting blood sugar again. If we put in some spaces around here, around these equal signs, it doesn't really matter. We can run this and this will work just fine. So spaces around equals are going to not really matter. Spaces around commas are also not really going to matter so much if you put a comma or not. If you have a space after this plus, it doesn't really matter. The spaces are going to matter the most if it is an object or a function or so on. And many people, many programmers will use underscore to make it more readable rather than what they call camel cases by putting a capital in the middle of the word or by just smushing it all together. So that's a great question. All right, so we're looking about themes. But here's the thing, very rarely will I, or will many people like spend time to modify their theme in a very specific way. Most of the time, there's a handful of preset themes, and these exist, and they're an easy way to change the entire theme of your graph quickly. You can actually do both if you want. You can say, I like this theme except for the title. I want my title to be like hot pink. And so you can say, I'm going to, because GGplot is going to evaluate and add these layer hierarchically, you can then add some custom sort of theme elements after a preset theme. So here's one example. So we've got GGplot heart. All of this looks the same. But then what we can do is we can say we add one more layer, just like we did. And this is now theme. But instead of theme parentheses, we have theme underscore minimal parentheses. And this is going to be a preset theme, which is called the minimal theme. And let's see what that looks like. And what we have is the first plot that we saw is on the left here. That's the one that we made, it's my first plot, and so on. Now the minimal theme is there on the right. It doesn't have that gray background. It's a lighter font. It doesn't have the background on the figure legend, and so on. So there are several, approximately 8 or so preset themes which are quite aesthetically pleasing and makes it sort of nice and easy to change several elements rather than going through and saying background is this and legend is this and and all of these different specific elements. So so just know that those themes exist, and there's also packages that have preset themes. There's a whole, again, world of packages out there that will allow you to download, like actually the BBC, the British Broadcasting Corporation, has a package that will allow you to download their themes. If you are a big fan of their data visualization tools, you can apply their themes to your plots and make them look like they're made at the BBC. So again, several different opportunities there. A couple of other things before we wrap up the GGplot part, which is I want to show you about saving plots. So now we've done all of this work to make our plot. We want to save it. And so there's a few ways to save it. The simplest is through ggsave. This is a function within GGplot. And so again, this is a function. So we say ggsave. We have a parentheses. And what we have here now is a file that we want to save to. So this is what we're going to call the thing that we're saving. And so we're going to save it as a PNG file. And our plot equals, by default, this is last plot. So this is convenient because you can put this last ggsave line right at the end of your code chunk. And then what it will do is it will make this beautiful plot, and then you can save it, and then you can save just automatically the last plot. If you take your plot and you pipe it to an object and you want to save that object, I did that a couple of times. I don't know if you guys noticed, but I was able to say plot 1, plot 2, and then I was able to show you both of them side by side. You could say plot equals plot 1 if your GGplot has a name. So that's another way to do it. You can also change the file type or the size. So for example, if you don't want a PNG, you want a PDF. So this would be a sort of pixels, and this would be vectors. You can then again identify my awesome object if you have that. You can change the height, units, resolution, dots per inch, dots, and so on. Okay, and then lastly, there's this great little function, get working directory, that will tell you where. So by default, this is just going to save in your working directory. So if you save your plot and then you go to look for it, you said, I lost it, where'd my plot go? You can say get working directory to, again, this just little function, it should tell you your path. And when you do this within, I'll show you, when you do this within RStudio Cloud, there's a crazy, let's see, there's a crazy directory that goes before this, that's some like temporary place. But if I then did a ggsave for this, I can actually just do that, ggsave, and then I'm going to say my first plot.png, and then by default it's saving the last plot, which is the one I made right over here. And if I look for it, it should be over here in my project file. And sure enough, my first plot is there. So that's the way that you are going to save those plots. Now, we have one exercise. I'll give you 5 minutes to go through this one. And then we have some more information that I want to share with you today. It's already 6 o'clock. I'm keeping my eye on the time. So there's a exercise that we put together, which is exercise number 7. And this is going to be compiling several of these activities. So you'll make a plot, and then you'll add some more to it, and you'll change it, and you'll keep going and keep going. And so this is to try to put these skills to work. So go ahead and take a little bit of time right now and see if you can work through that. Again, if you have questions, ask on the question board, and then we'll move into 2 other important elements, which are going to be the stringer and importing. So go ahead and start with that now. All right, welcome back. We have about 20 or so minutes to get through a little bit more material, so we're going to continue along. If you didn't finish that quite yet, and you have some questions, go ahead and again ask. What I'll also mention is that within this miscellaneous folder within the code directory, I put a sort of an answer file. There's no absolute right way. Again, you can write code a lot of different ways, but after you're done working on it, you can take a look at that. Or if you get stuck and we're not able to slow down and tell you exactly what you could do, go ahead and take a look at that file. So we want to then cover just a couple more things before our time together is done. So the first is importing. So far, we've shown you all of these data sets and given them to you by this simple script. But that's like a rare thing to do, because most of the time in the wild, you'll be getting a data set from a collaborator, from a repository somewhere, or so on, and you're going to need to import that into R. And so there's a great package called Reader, and Reader has a series of different functions called read underscore and then some function. So if you wanted to read a CSV file, you would say read underscore CSV. And again, get very comfortable and very familiar going to the help tab within RStudio, and you can type in read underscore CSV, and you can see all of the different sort of information that this is expecting, and then also if you need to skip lines, if you need to include headers or so on, all of that is there, all the documentation. So the data set that we provided is cleaned, but you're never going to find this in the wild. So you'll find a data set and you'll import it, and the way that you do that is with this reader. So for the purpose of this class, so far we've been using this data set that we call Heart. And Heart is a data set that, again, is from this compendium of different heart disease data sets located all across the world. And what we've done for the purposes of this class is we've simulated a data set of pseudo-patient histories for these patients to accompany this heart data set. So we've done this for two purposes. The first is so that we can import this CSV file and see and feel what that's like. But then also we have some text information, and oftentimes you'll be dealing with text. And so we want to then take that text and learn how to manipulate it. So we're going to now spend the next little bit working on importing this file and then dealing with some of this text. So we have something called PHX for patient history, and this is a CSV file, and we're going to import this into R by running the following. So we have the command is called read CSV, and then we have this other little package that I want to take a second to tell you about. This other little package is called here. And here handles paths quite simply and also quite reproducibly. And so what you can write then is within the here package, there's a function also called here. So what you can write then is here, and what it's expecting is a string of where your object is located. And this is separated by a folder, another folder, and so on until the last thing it's expecting are your data. So what you would then is you say read CSV. What am I reading? I'm reading a file that's located at this path. And I'm going to then assign it to an object that's called patient_hx. So go to code folder, open up number 8, exercise number 8, and we'll just take 2 minutes and go ahead and import this exercise. So you can go ahead and do that now. All right, we'll stop a little bit early just because I want to make it clear. I don't want you to do this joins yet. So really what I want you to do is just to run this code here and to import your data. So hopefully you were able to do that. This explains this great little here package, and you should now have an object in your directory that is this called patient.hx. So if you click on the environment tab up here, you've got a couple of different objects already up here. What you should have is one that's called patient.hx. So if we then go something like this, and we go like this, and we run this code, well, let's make sure that we run this first. We run this first, and then we want to run this one. We should now see that we have patient_hx in this in our environment. So so that's how we import things. And there's again great documentation. If you come over to the help file over here, or the help tab, you say read CSV. You can then say all the different types of files that it's expecting, all of the different information, and then again get comfortable and familiar reading this this help documentation. Okay, so we've got a file in there now. And this object is patient.hx, and this is helpful. So what we can also do sometimes, and this is useful for data provenance issues, is we can also import data from a URL. So for example, this is a path where we said here it's located at data. Now, if I was going to then just share this with a colleague, I would then have to like email this, or there would be some issues with data provenance. The other thing that you can do is if the data is located at a public repository, you can identify the path to that repository and its URL, and then you can just assign that to URL, or you can just put the whole thing here, and you can then say, I'm going to read this path from the URL. So just keep in mind that you can point to a local path, or you can point to a path that's on the internet. So we've got a question: how do you specify the full path without setting the directory? So that's a great question. Again, for simplicity purposes, I've tried to use this here package, which then is going to make things simple for you. I'll just show you that if you come to the RStudio, and then we open up the console here at the bottom, and we clean this to make it easy. I'm not sure if you guys will be able to see this, but if we type here, let's see, like this, it will tell us our path. And so when I say here, here, I say this is the path. If I say here, and then it's expecting, let's see, project. So then I can say over here, code, and then I can say within code, there's, let's say a file. I can then point to, I can point to that file. So what here is doing is it's basically stitching a path together. If I say that I want to import, something, so I can say read CSV, and I can just type in my path, to my file. That's not a file, that's just a folder. That would also work. But again, where the slashes are and like the working directory and all of this is like a little bit cumbersome. So I tried to make it simple, where if we say git working directory, that tells us our working directory is here. If we say here, it tells us our here directory is also here. Sometimes your working directory can be in a different place. So it's always good to know when you're defining what you're importing, where you're importing it from. So great question. All right, continuing along. So now we have a data set, but now it's a nice data set. It's our patient history data set. Again, full disclosure, totally simulated patient history data set. But now we want to combine this because we want to ask some questions about these patients and maybe like the medications they're on, and if they are the ones on the medications that are have the right the appropriate disease it's trying to treat, and so on. So we can now think about wanting to join these two data sets. And so what we need to do to join these is to make sure that we have at least one variable that's overlapping between them. We actually, going back to dplyr now, this dplyr package that we talked about yesterday, that has several verbs or several functions that allows us to join packages. So I'm going to show you just a couple of those here and really just kind of conceptually go through some of these different joins. Okay, so the first one is called a left join. And the left join, I'm going to actually come back to here. So the left join, this first one, is going to, this is the best picture. So let's say we have a data set A or data frame A and data frame B. And you can see that there are some values in A that match. So X1 and X1 are both in each data frame. So we're going to match on those. But you can see that it's not perfect because like A has A, B, and C, and B has A, B, D. And so what we want to do is we want to then say, which ones are we going to keep? And then how does the behavior change if we don't have something? And that's really what all of these joins are about. So the left join, which is probably the most common join, is going to then be to take A and B, and it matches these joining rows from B to A. And this is what happens. So we take all of our values from A, we match the ones from B, and if it's not there, then we just leave it blank. Okay? So that's what this looks like. This is what it's just written out. So rows with no match in B will have any values in the columns. And then take a look at each of the variables in each data set. We have heart and we have patient. You'll notice that each of these data sets contain a common variable, patient ID. This is going to be the common variable to join on. So now what I want you to do is in just a minute, you're going to go back to that exercise, which is import and join, and try this left join. So what we want to do is we want to left join heart with patient history and assign the output to a new object called heart join left. So it's going to look something like that. What I want you to do is I want you to open up this 08 again. And I want you actually just for practice to go to the help documentation. So go to the help tab and type in left join. And look at the variables and look at the ways that it's supposed to stitch together. So I'll give you 2 minutes again just to go through and try to finish now this, this activity, which is going to be to join our, this last part is going to be to left join of these two data sets. So go ahead and give that a shot now. If it doesn't work, try it again, and then we'll come back and we'll discuss it. All right, welcome back. So the way that we would approach this left join would be to start with heart. That's a nice way to start. And then what we want to do is we want to, and then pipe it to a function called left join. This left join is expecting two variables, expecting x and y. Well, we already defined x because it's getting x from here, from heart. So really what we want to do is we want to tell it what we're going to left join it with. And this is going to be the data set that we already imported, which is our patient history data frame. But then what we also need to do is we want to define what we're joining it by. And if we go to the help page, we can see that by needs to be defined. So right here for our left join. So our by is going to be patient ID. And if we do this, we can see that we would have patient ID, and now it's got both all of our original columns from heart, and it's also got all of our new columns from our joined. So then what we want to do is I said that we wanted to save it as heart join left. So then we go heart join left, and we go like this. And we can see now in our objects in here in the upper right, heart join left is going to be 18 variables, which is going to be our original 15 from heart. We have 4 from patient history. Well, 4 plus 15 is 19, but recall one of these is going to be the same, this patient ID that we used to join on, so it doesn't duplicate patient ID in both. It's going to use that for the join. So that's why we have 18 in our heart joined data set. All right, so that's going to be the way that you're going to then approach taking some data, importing it, combining it. So now we talked yesterday about selecting to get rid of some columns. Now we can use read CSV and then join to import into assigned columns. So there's several other different types of joins. For example, right join is going to then take, it's the opposite of left join. It's going to take, instead of matching rows from B to A, it's going to match from A to B. Inner join is going to be a little bit different. We'll go through these a little bit quickly. We're not going to practice these, but I want you to remember that there's several different types of joins. Again, that can integrate data in different ways. So our inner join is going to be a little bit different because it's only going to contain data that's in both data sets. So if you look here for our left join and our right join, I said that we've got some missing values will be NAs, whether you're joining this from the left or the right. Here, if you are missing a value, it's going to be absent. The last join, so that's just what I wrote here for you all. The last join that would be good to know about is a full join, and this is where you retain all values from all rows. So nothing is going to be dropped, and everything is going to be integrated. So there's 2 other joins we're not going to talk about today that are also going to be more sophisticated, but again, for this entry level, what we're trying to do is just give you a sense and have you practice joining some of this information. So I'll just mention right now, there's 2 more things that I want to go through with you. I want to go through strings, and I also want to go through reproducible reports. It's just about 6:30. So several of you emailed me yesterday letting me know that you would have to drop out a little bit early, and the live stream then was converted to a recording. So hopefully for those of you who missed the end of the talk yesterday, you were able to pick up on that. So it's just about the end of our scheduled time. But what I'm going to propose to do is to continue. If you can stay for a little while longer, maybe another 15 minutes or so, then great. If you can't, then remember that this video will also be converted and basically stored on YouTube, so you can watch this at another time. So if you have to go, I totally understand. I will be sending an email tomorrow with links to both videos. And then also the last thing that I'll mention is that we've got a special treat for you guys that I was able to secure access for you to have to a learning platform for data science for the next 6 months for free. So as members of this class, I was able to do that for you. So I'll send an email to all of the course registrants tomorrow about that information. So I don't want to just zip through all the information, and I don't want to just stop because there's some important things we want to get to. I want to sort of be respectful of your time and acknowledge that we're almost to 6:30, the planned end time of this, and we'll just have a little bit more. So now is a good time to ask questions about importing or joining before we transition into our string lecture, which is essentially thinking about how to handle data that aren't numbers and the different types of things that we can do to that. So go ahead and again, ask questions on the question board if there's anything else that you want to for me to clarify. But otherwise, what we're going to do is we're going to transition now to the penultimate of the 2 topics I want to cover. So in order to think about strings, we want to get back to this idea of what a string is. And remember, a string, quite simply, is something that holds text or stores text within it. So strings can be a single word, strings can be a sentence, or strings can be a combination. You can basically, excuse me, have several different strings that are stuck together. So if you want, you can essentially write some strings in this text box. You can store these strings as objects. We did this very, very early on. So let's say we have an object that's called my name, and we can put this here. So now we have an object, and if we call my name, we can then see that this is a string because it's in quotes. So next, we can do some different things with these strings. They're a little bit interesting because it's a little bit different than dealing with a number and R. Essentially, what we need to think about is how do we do things like sort and select and change some of these strings? So change some of them. So fortunately for us, there's a package within the Tidyverse called Stringer that's exclusively designed for dealing with and manipulating strings. So this link doesn't seem to be working, but essentially here's a page that you can come to that looks at the Stringer package information and overview. Of course, there's a cheat sheet. There's a cheat sheet for everything, it can give you more information if this is something that they're interested in and you want to learn more about. Okay, so we can start out by counting strings. And so there's a function called string count. All of the string functions are going to start with str, and this is going to be a consistent and simple way for you to remember that these strings or these functions are going to be dealing with strings. So string count is a function that we use to count the number of rows that match a particular pattern. So we need to think now a little bit about the way that we're going to be dealing with strings. So in the simple example of my name object is Matt, I can then look for the entire object Matt, and it could count the number of rows that contain that. When we count something, the output is either going to be it matches the string or it doesn't match the string. And that's what this looks like here. So if we want to evaluate, let's say, health status, and health status is going to tell us something about if a patient is healthy, if a patient isn't healthy, if a patient has high cholesterol. And so let's say the pattern that we want to count is high cholesterol. So the way that we would do this then is we would use the function string count, just like we have here. Next, we're going to identify where the information is that we want to count. So in this case, this is within heart joined, and one of the columns here is health status. And then we say the pattern, and the pattern here is going to be the entire string, which is high cholesterol. And when we do that, what we find is that we have a bunch of zeros and ones saying whether or not this string count is going to match high cholesterol or not. And so we've got all of these then zeros and ones, and that is going to be the way that string count is going to convert this pattern, which is high cholesterol, into a number that we can do something with. Okay, but it turns out the zeros and ones, like that last page, isn't very helpful. So we can wrap the whole thing in another function, which is called sum. And sum, as you might predict, is going to just add things for us. So if we run this, we get a lot of zeros and ones, not super helpful. But then if we go and we wrap the whole thing in sum, we can count and we could say, oh, it turns out that in our data set of 1,000 people, 1,025, 503 of them have a health status that is identified as high cholesterol. So that's one way that we can use string count. We can count this information, we can look for this pattern, and then we can then use sum to identify the total number of people that have that pattern. Okay, but what if we have subsets? What if we have something that's not high cholesterol, but we want to match a subset of it? So we previously, again, looked at the entire word, but we can use the same type of function to detect patterns within longer strings. So another example we can look at is how many patients take a statin. Again, this is a simulated data set. So we simulated how many of these patients might be on statins. And we can use in string count, and we can then look within the medication history. And here in this case, there are several different medications. but statins all have the word statin in there, lovastatin and so on. And so then we can look for part of the word and do the same thing. So when we go like this, we can string count. We can then look here, and we can see zeros or ones, whether it's detected or not detected. There are some NAs in here, and these NAs are going to then tell us that these are values that could not be evaluated. And so in this case, it can't tell us whether or not the string was detected or not, probably because there was an NA within the data set. So an NA is just sort of empty value, and empty is going to be very different, or NA is going to be different than not there. So just an important point about NAs. All right, so we can ask a question about the a sub part of the string. We've got a great question here that I'll sort of highlight. Does the case matter in pattern search? And Ali has already chimed in saying, yes, this does. This is important. So if you look at, we're going to talk about case in just a moment, but yes, case is going to be important. In fact, I have a note here about strings. If you get an output saying that the string doesn't exist, and you know for sure it does, double check capitalization. Again, the string must match exactly, or it won't be found. So that's important. Let's see. Moving along here. So we have a little stringer exercise for you. So the first exercise is in number 9. So go ahead and do this. And this is going to ask how many people have an auntie or an aunt in their health history. All right. So go to code number 9, and we'll just again take 2 minutes and you guys to try to do this exercise, and we'll answer some of the questions on the board here. All right. We also provided you the answer key to the number 9 activity. So I won't spend too much time going through that right now, but I'll just show you it's in the same place as some of the other ones. So if you go to your code folder in the project folder, in miscellaneous, you can see the stringer answers file right here. So that will give you some time to go through it and to essentially check some of your answers, some of your work. All right, so that's one thing that we wanted to show you just about matching these. Generally, what we'd say is that if you want to then match auntie or aunt, then what you could do is you could look for the word aunt, which is going to be in both of them in one example. And so in this case, it'd be quite easy where we could then say, is it auntie or aunt? and really matching part of this that's going to be unique from the other words that you're matching, but also common between them. So that's just one strategy. And actually one other thing that I would mention is that this would work in this simple case, but it's not very elegant. And in fact, it might not work in all cases, because if there was a great aunt in the list, or I think there might even be some capital aunts. And so you could then search for like UNT, but again, the UNT would work for the capital, but not if there's a great aunt in the list. And so one of the things that we want to then look at is whether or not there's a more specific way to be able to say exactly what you're looking for. And there is, and it's this entire new language that we're going to pile on top here now. You're learning R, you're learning some of the tidyverse, and now there's a new language which is called regular expressions. And regular expressions is one way that you could very specifically identify the word that you're looking for and the pattern that you're looking for. So I want to show you an example of what a regular expression looks like. So it's essentially a way to convert a word into a symbol that then is going to match a certain set of rules. And regular expressions are far too complicated to cover in its entirety here, but I want to show you just one example. So let's say the goal is to identify all of the patients that have a father with a history of disease, but excluding grandfather in the results. So what we need to do is we need to think a little bit about what that might look like for us to match father but not grandfather. So one thing that we could do is we would want to say we want to start by recognizing father but not grandfather. And the way that we could do that is make sure that the first F is at the beginning of the word. The next thing that we would want to do is we want to make sure that we capture both capital father and lowercase father. If you're looking at like real text data, it's a mess. And what you need to do is you need to then consider, did people actually capitalize father each time, or was it just a lowercase father, but it was at the in the middle of the word, and so on. So you need ways to do this. And in this case, we can accept either F in the first spot, and we add this OR command. So this long line, which is right above your enter key or your return key, so it's shift, and then that slash, but it's a straight line up and down. And so what you would do is you would say your regex would look something like this, where you have an F or an F, so capital or lowercase f, and then father. We want then to appear at the beginning of the word, so it doesn't capture grandfather. And so then there's another symbol, and this is where the regex comes in. This regex symbol is going to be this little caret, or this shift number 6. And this then is going to be the code for I want to look for father, and it looks like this. So we string count, heart joined, family history, this is where we're looking for it. And this pattern that we're looking for is inside of this code still, but now it's a little bit more complex. And this is where the regex comes in, where we have a capital F or lowercase f, and this is in parentheses, so you say it's either of these. And then this tells us that this is at the beginning of the word, and that then will match father or father. So this is a sense of, I'll give you a sense of how it would look. And so you could play with that here if you want, but again, we're running a little bit late on time. So if you want to, or you haven't completed the rest of the 09 stringer, I only gave you 2 minutes, and this was a little bit more complicated. You could use the same example exercise to count mothers, but again, given some of the time, we'll go ahead and let you do that later on your own time. And recall that within the miscellaneous folder, within the code folder, is an answer key to check your work. So there's plenty of regex resources. So this is one from the Stringer website, where you can follow through this information here and look and see about how some of this regex works. And of course, there's a cheat sheet, and the cheat sheet has some regex on it, and that's a great resource, especially for some of the more simple regexes. So the other thing that we can do, in addition to counting, is we can use another function called string detect. And string detect is going to be a little bit different than string count, because string detect is going to then logically evaluate whether a character string is matching or not. And so essentially it's going to then say the output is either going to be true or false. And so practically string detect is oftentimes used to say, is the pattern there or is the pattern not there, rather than counting. Because counting, what you could do is you can end up counting several patterns within a string. So this is really just going to condense it down to does it detect this string in this a match or not? And so if we wanted to, we could then take something like this, and we could say how many matches for a diabetic do we have when we run the code, and we can see, again, this is a logical evaluation, so it's true, false, saying is diabetic matching within this or not. So the last thing that, that we want to do sometimes with strings is going to be to modify the strings with string replace. And so here what we have then is going to be a simple example where we have health status. In the health status column, we have 3 different examples. We have diabetic, we have high cholesterol, or we have normal blood sugar and cholesterol. But let's say that we wanted to change that and simplify normal blood sugar and cholesterol to just normal. And what we can do is we can use a function called string replace. So again, what you should start to see with all of these stringer functions is that these are going to take the where am I getting this information, and then what am I matching? And so in this case, we have a third argument here, or in this case, a second argument, where what am I matching, but then what am I replacing with? And so if you look up string replace within our help over here again, string replace, you can see that what it's looking for is a string and the pattern, but then it's also expecting a replacement. And that's exactly what we did here, the string, the pattern, and the replacement. Okay, so if you want, you can try that on your own. And you could use the same code to modify health status column by assigning it a new variable or the same variable. So let's say if we go back one slide here and we just run this, what we would do is we would then, run this, and then we come over here, and it's basically going to then give us all of our normals, because if it detected our normal blood sugar and cholesterol, it's going to give us our normals. But in some cases, we want to actually change the value, and so one way to do that is we can replace this string by just saying, this is a string that we detected, and this is one way to replace it. There's a couple of other ways to replace it too. We could use some pipes and we could use some mutates and things like that. But the key thing here is that if we just use string replace by itself, it's not going to replace any of the original objects. We need to then tell it what to replace if we want to replace it in that in the same object, or perhaps we would want a new object, and that would be the way to do it. Okay, so again, I told you there's a couple of ways we can do this. We can also do this with the plier. And so we can make a logical variable. In this case, we're going to use string detect along with mutate. And that would look something like this, where we have heart joined, and then we mutate. Healthy equals, if you recall, the mutate function is going to tell us whether or not we have a, we're going to make a new column in our data frame. So in our heart joined data frame, we're going to make a new column, and this new column is called healthy. And we're going to populate that column with the output of this function. So you can start to see with this pipe how we can start stringing some of these ideas together. So now we're saying healthy is going to be true or false. If it's normal, then it's going to be true. If not, it's going to be false. And so then if we wanted to, we could then assign this to the same object, or in this case, we'll assign it to a new object for this example. So again, I'll let you guys do the code on your own. There's a couple of other things that you can do at the bottom of that code to complete the exercise. So don't worry about that for now. Again, it's getting a little bit late. But there's one last thing that I wanted to show you guys within this R Markdown world, which is the reproducible reports. So I will take a second, though, and just ask if there's any questions. I saw a couple of questions come up, and we've already covered them, which is, just one of the questions was, does string replace affect the original file? Again, no, by itself it doesn't, but when we assign it to a new object, it can. So, all right. So then the last couple of things with this, R Markdown. So we've worked a lot with these R Markdown documents, but really the power of this R Markdown comes with the scientific reproducibility and provenance, where we can use this R Markdown to intermingle code and text and so on. And so within our R Markdown, recall that there's really 3 different types of content, and this is what we're going to talk mostly about right now. One of the pieces of content, we haven't talked much about this. This is called the header. We'll talk about that in just a moment. Then we've got text, and that's written in Markdown. And then finally, we've got these code chunks. We've talked most about the code chunks, but if we're starting to think about reports, then these other 2 elements will become important, which is our header and our text. Okay, so we have a button here we haven't really talked much about. It's called knit. And the knit button is going to convert our R Markdown document, which looks like this, into text. And so on the left-hand side here, this is just a simple example, a screenshot of an R Markdown document. And on the right-hand side, this is what the text looks like, or this is what the report would look like that is output from this. Okay, so how does this work? Well, what we do is we take the R Markdown document, and then we knit this, and this is a package that then will convert this R Markdown into Markdown, which then is going to convert this into many different types of formats. And this is great because there's several different types of formats that we can generate, including Word documents, including PowerPoint files, and in fact, including this presentation that I'm presenting with you right now. So there's a couple of key points, though, is that that I want you to take away from this knitting idea. So we take our code, and knit runs the document in a fresh R session. So I get so many knitting errors because when you knit, it will make sure you have all of the objects and everything that you need in a fresh session. So you need to make sure that everything is there and it's going to be evaluated in this logical order. Of course, just like our coding, objects in one code chunk are available to code chunks later, but importantly, it's not before. So for example, we made, through a left join, you made this heart joined data set. Well, it turns out that if you then wanted to do something with heart joined, but you did it before you actually made it, your knitting would break because you need to sort of evaluate this in order. It's really not that hard to keep it straight. Really what you just need to do is think about sequential code chunks. Okay, so these are the key points. There's this entire guide to R Markdown that tells you all of the different output files and formats and so on. So I'd encourage you guys to look at that. But it's pretty amazing that you can have a single R Markdown document and that you can compile several different PDFs, HTML, Word documents, slides, journal articles, books, websites, so on. This is really the amazing thing, and all of this is coming from where we write our code. So what I want to do is I want to then just show you this R Markdown text, because what you can see is that even in my slides, I have some headers here, and then I have some normal text and so on. And there's a really specific formatting way that you can write this. And so again, or yet again, here's another language for you. So Markdown provides an easy way to make standard types of Markdown text. So if you want to make something italics, you would just take your normal text and surround it in a star. Bold is 2 stars. And again, this is another language. It's not incredibly important to know at this point, but what you can see here on the left is this is what the text would look like in your R Markdown document. On the right, this is what the knitted document looks like. So, R Markdown can mark up, text to be bold, italics, code, and so on, links and all of this. And so just showing you that this is all from that text that you write in your R Markdown documents. Of course, there's a cheat sheet, so just point you to that has the information that you need about the R Markdown. So you'll be able to then look and have a quick guide, essentially. How do I make bold again? How do I make a numbered list? And so on. So that's the text part. So I said that there are 3 elements that we're just going to wrap up with. So the text. One is also this code part. So the codes are written in these code chunks. You know that. And these are surrounded by these ticks. And they are then going to insert a code chunk for you to write code as you're moving through this document. I would encourage you to get familiar and get comfortable with this, with these code chunks shortcuts, because you're going to be inserting so many of these that it's a little bit foreign at the beginning. But actually, I don't even know what buttons I push now. I would have to like look at the keyboard. Like this is how like intuitive and familiar it becomes. So get familiar on the Mac or on a PC to insert these code chunks, which is going to basically put in an inline code chunk template for you. A couple of things to note is that, and now this is going to be very specific for generating types of reports, you can include different types of information here. So here's a function, it's dimension. This is a data set called iris. And what we have here is that if you have code, and like this is text, this is a code chunk. And what we have now is when it's rendered, you have both the code, the text, the code, and then the output. But you have different options for these code chunks. And we'll go through these quickly. Again, it's just getting late, but what you can do is you can actually include or exclude different types of information from your code chunk to be included in your report. So as one example, if you say echo equals false, what you see here is like, here's some code, that's the text, this is your code chunk, but it actually doesn't show the code. So when you say echo equals false, it hides the code and it just shows the output. So this is useful for making plots if you don't want to show the plot for the code, if you want to have some text and then a plot. This is useful where it will then not include the code. Evaluate is also useful if you want to have some code, but you don't want to be evaluated, you just want to show it. You can then have this here. So the thing that I'll mention, there's a question about spaces. So you can't really see this here, but what I'll do is I'll just take a moment and come here, that if I want to have if I want to change my my code chunk option in my RStudio Cloud, what I would do is I would list. This is actually what I would do is I would list right here my like echo equals false. So what I want is a space in between R, and then I want to have echo, which is my code chunk option, and then I say equals false. If I don't have another one, I can put a comma, a space, and so on. So there's a question about spaces, so I just wanted to mention that. We also have include. So include runs the code, but it doesn't, include equals false runs the code, but it doesn't include the code or the results from appearing. And then you can also, if you're making a lot of plots, you can set some figure height and figure widths within the code. So these are more advanced, like sophisticated things if you have a report and you want to make your report look like a very special and specific way. But all of this is going to happen by modifying that code chunk. Okay, so we can also then take an object from our code and we can place it within the text by calling this inline R code. And so what we do is we basically make a backtick, a lowercase r, a space, and then we have some code here. And so it looks a little bit like this, like today is space, and then we have system date, and this is then just going to print the date. And this is a way that we can have some R code outside of a code chunk sort of intermingled within our text. All right, so again, this is what it would like specifically look like. There's a space, backtick, R, and so on. So it wraps this backticks around your R function. Okay, so I'm going to skip this. I'd like you guys to do this if you're interested in more of this R Markdown. You can then go through and follow these instructions in order to just, again, have a little bit more practice with your R Markdown document. The last thing that I'll mention is this, this third component, which is this YAML header. YAML stands for yet another markup language. And this is then going to help you do something called parameterize your report, and or it's going to identify specifically how you're going to output your report. So for example, right here what we have is a title, an author, a date, and then output equals HTML. So when we click that knit button, what we're going to do is we're going to convert it to an HTML. If we change that though to PDF, then it's going to make a PDF and not an HTML or Word document or so on. So again, this is just taken from the cheat sheet where we have the different types of documents that we can take. So when you knit your R Markdown, you can make several different types of documents. So there's one last exercise that I'll just mention, which is rendering some of these with parameters. And so you can then also define a parameter in that Markdown header where you will be able to then populate different values of your report based on how you define it. So again, these are more advanced report reproducibility things, some things that you can go through on your own time. And so here's this a parameter example. Let's see, that you can then, again, the exercise will be a little bit informative to tell you about how to use some of these parameters. All right, so then a couple of concluding thoughts. And so one concluding question we have is, it'd be great if you can inform us about other courses related to R or data science in the future. Absolutely, we're rushing a little bit here at the end, hopefully not too much. I'm still trying to give you guys some good information. I am going to send an email tomorrow about 6 months of access to a data science learning platform that will allow you to continue taking some online classes, practice, and so on. So if you've liked what you've seen here, that would be a good way to continue some of this online learning. So look for that email tomorrow for all of the course participants. Okay, a couple of concluding thoughts. What we have here is this idea about data science. And data science, I think, enables data-driven information gathering. Data science enables ability to ask new types of questions. Again, this is in this healthcare focus, but data science is used in all different types of fields. You know, the really important thing I think here is that these data science workflows save time and they also achieve reproducibility, which is one of the most important reasons that we do this. So some of the resources I've mentioned throughout the course are these cheat sheets. There's several of them. Stack Overflow is a website that we've also talked a little bit about that answers lots of questions. We've got R for data science. If you want to dive deep into using R for data science, I would recommend either buying this book or accessing this book for free online and seeing if we, and basically following through. There's exercises and all sorts of learning opportunities there. And then there's also a resource called Tidy Tuesday. And Tidy Tuesday is a data visualization opportunity where every Tuesday a weekly data set is sent out for visualization challenges. And so the last thing I'll just mention is just some acknowledgments. So of course, the indomitable and inexhaustible TAs, Ali and Akshay, thank you for all of your help manning these boards and questions. Then again, I just need to acknowledge R for Data Science and people whose information and teaching materials that they've made available to share to help inspire a lot of the information in this course, and then also you. So we're about 30 minutes over. Thank you for staying this long. And let's see, all three of you, that's Ali and Akshay. No, just kidding. So if you guys have any other questions, we'll go ahead, we'll hang out for a few more minutes. But otherwise, thank you. I hope that you've enjoyed it. I hope that you learned something. I hope everybody is staying safe and healthy, and both mentally and physically. And if you have other questions, go ahead, reach out to me. Like I said, look for that email tomorrow, and hopefully this sort of gets you going on your own data science journey. So thank you.